Hi, everybody. It's Professor Mitchell, continuing with Chapter 12. Today, we're looking at Section 12.6, Properties of Logarithms. All right, so this section examines several properties of logarithms that allow you to simplify expressions. Recall that a logarithm is an exponent. So logarithmic properties are restatements of exponential properties. And I'm going to explain one of these in a little more detail. All right, so the first property is called the product property, and it says that if x, y, and b are positive real numbers with b not equal to 1, then log base b of x times y is equal to log base b of x plus log base b of y. In other words, the log of a product is the sum of the logs. Or put another way, note that this property allows you to split the logarithm of a product into the sum of two logarithms. We can also use the property to consolidate a sum of logarithms into a single logarithm. All right, so here's where I can't resist spending 2 minutes explaining to you why this works. I don't like because I said so. So suppose, for example, that log base b of x equals 3 and log base b of y equals 5. Okay, just an example. Then if we put those statements into exponential form, and you might want to pause the video for a minute and think about this, that would say that b to the third equals x and b to the fifth equals y. So now let's talk about x times y. X times y would be b to the third times b to the fifth, and here's where the magic really happens. Remember that b to the third times b to the fifth is b to the power 3 plus 5. You add those exponents, and that gives you b to the eighth. So now we have x times y equals b to the eighth. Putting that back into logarithmic form, that would say log base b of x times y equals 8. And remember, the 8 came from 3 plus 5, which is log base b of x plus log base b of y. Okay? So that just gives you a little idea of why this property works. So now let's do some examples. Write each sum as a single logarithm, starting with log base 7 of x plus log base 7 of 4. So remember, the log of a product is the sum of the logs, or the sum of the logs is the log of the product. And so we can combine these two logarithms into log base 7 of 4 times x, which of course can be written as log base 7 of 4x. Okay, pretty simple. Log base z of 5 plus log base z of 8 would be equal to log base z of 5 times 8, which is log base z of 40. All right, here's a slightly more complicated example. Log base 2 of x plus log base 2 of 10 plus log base 2 of x plus 3. All right, so first, oh, never mind, they did them all at the same time. So notice that we're adding 3 logarithms together here. So that would be the log of the product of these 3 things, x times 10 times x plus 3. So that's how they got that. All right, I probably would have shown just a little bit more work there, but hopefully you get the idea. Okay, now, if the log of a product is the sum of the logs, the log of a quotient should be what? Should be the difference of the logs. Okay, just makes logical sense, I think. And that's exactly what happens. Log base b of x over y is equal to log base b of x minus log base b of y. So my favorite way to say this again is the log of a quotient equals the difference of the logs. Note that this property allows you to split the logarithm of a quotient into the difference of 2 logarithms. We can also use the property to consolidate a difference of logarithms into a single logarithm. So that's what we're going to be doing here. Write each difference as a single logarithm. Log base 7 of x minus log base 7 of 4. The difference of the logs is the log of the quotient. So log base 7 of x minus log base 7 of 4 would be log base 7 of x over 4. And then log base z of 40 minus log base z of 8 would be log base z of 40 over 8, which is log base z of 5. All right, and now write the difference as a single logarithm. Log base 4 of x minus log base 4 of 10 minus log base 4 of x plus 3. Now, you may have noticed for the last few sections, the solutions to all these problems have been right in the PowerPoint. I haven't been needing to switch over to my tablet. Well, for some reason, I don't have the solution of this one in the PowerPoint. So I am going to switch over to the tablet. You haven't seen me do this in a little while. All right, here we go. So you do have to be careful with differences, especially. So I'm just going to take this 2 terms at a time, and I'm going to go from left to right. So what I would do first is combine these 2 logarithms into log base 4 of x over 10. You don't technically have to put parentheses there, but it does make it a little clearer, I think. Minus log base 4 of x plus 3. Okay. Now notice this is still the difference of 2 logarithms. So when I combine these 2 logarithms into a single logarithm, it is again going to be a quotient. So it's going to look like this. Log base 4 of the quotient of x over 10 and x plus 3. Okay. Now, hopefully you remember from chapter 7 that we don't like complex fractions. And when I say we don't like them, we just don't like to leave our answers as complex fractions. So let's simplify that complex fraction. I'm going to multiply the top and the bottom by 10. And that's going to get rid of this 10. And for my final answer, I'm going to get log base 4 of x over 10 times x plus 3. All right, and that looks better than the previous version had looked. All right, and that's all there is to it. Okay, so now I think we're ready to talk about my favorite property of logarithms. Which is the power property of logarithms. If x and b are positive real numbers with b not equal to 1, and r is a real number, then log base b of x to the r is equal to r times log base b of x. So let me show you one reason why this is my favorite property of logarithms. It's because it has a sound effect that goes along with it. So whenever I use the power property, I like to do this. I like to say, oh, darn it. I was talking for too long and then my pen disappeared. Almost ruined the moment. Okay, so here's what I do. I grab that exponent and I go, all right, slam it down front. Okay, that's what the power property does. All right, so let's, yeah. All right, first we have log base 7 of x to the power negative 3. All right, so grab my pen. Log base 7 of x to the negative 3 is negative 3 times log base 7 of x. All right, now log base 5 of the cube root of x, the first thing we have to do is write cube root of x as a power of x. You remember how that works? The cube root of x is x to the power 1/3, right? Oh dear, okay, so they left a step out here. Hold on a second. Yeah, I'm not comfortable leaving out the step that they left out. So the first thing I would absolutely do is rewrite that cube root of x as x to the 1/3. Okay. And now I can take that 1/3 and go, and that is how that 1/3 ends up out front. So you get 1/3 times log base 5 of x. For those of you going on to calculus, which in Math C, I assume is everyone, even though I know it's really not, we use these properties all the time in Calc 2 to do something called logarithmic differentiation. Doesn't that sound fun? All right. Okay, so let's go back to the presentation. All right, so now we're going to write this expression as a single logarithm. 2 times log base 5 of x plus log base 5 of 4 minus 3 times log base 5 of x plus 5. All right, so first step, I have a slightly different sound effect for this. When I'm using the power property in the other direction, instead of going, I go. All right, see, the first thing we need to have happen is we can't have any numbers in front of the logarithms. So then I'm going to do the same thing over here. All right, so that's how we end up with log base 5 of x squared, and then over here log base 5 of x plus 5 to the third. So now we're going to use our product and quotient properties. And again, I might have done this in 2 steps. So the first thing they did was they combined log base 5 of x squared plus log base 5 of 4 into log base 5 of 4x squared, log base 5 of 4x squared. And then they used the quotient property to get this final answer. And let's see. Okay. Now we're going to write this expression as a sum or difference of multiples of logarithms. So this is expanding the logarithmic expression. All right, so the first step is we're going to use the product and quotient properties. First, to rewrite this thing as a difference, log base b of x cubed z minus log base b of the square root of y. And then you can break log base b of x cubed z into these two terms, log base b of x cubed plus log base b of z. And then finally, we're going to use our power property. We're going to take this 3 and we're going to go, all right, and then remember that this thing here can also be written as y to the 1/2. So we're going to take that 1/2 and we're going to go. All right, so when I click, I have a feeling you're going to see, yes, 3 times log base b of x plus log base b of z minus 1/2 log base b of y. All right. If log base b of 2 is equal to 0.43 and log base b of 3 is equal to 0.68, let's use the properties of logarithms to evaluate log base b of 16 and then log base b of the 4th root of 3/2. Right? I enjoy this kind of problem. All right, so for letter A, we're going to rewrite 16 as 2 to the power 4. See, we need these numbers 16 and 4th root of 3 halves to be all about the numbers 2 and 3, all right? So that we can use those properties of logarithms. And now I bet you know what I'm going to do next. I'm going to grab this 4 and I'm going to go, and that's going to give me 4 times log base b of 2. And we know that log base b of 2 is equal to 0.43. 4 times 0.43 is 1.72. All right, now log base b of 4th root of 3 halves. So remember that 4th root means 1/4 power. So we would take that 1/4 power and go, gives us 1/4 times log base b of 3 halves. Now remember, they didn't technically tell me what log base b of 3 halves is, but they did tell me what log base b of 2 is and what log base b of 3 is. So now I'm going to use the quotient property to rewrite log base b of 3 halves as log base b of 3 minus log base b of 2. And now I think we got it. Log base b of 3 is 0.68. Log base b of 2 is 0.43. All right, and crunching those numbers, you get that that comes out to 0.0625. And that's going to do it for section 12.6. We'll see you next time.